Okay, so let's look at this a little bit more. So drowned river valleys, as I said, rivers tend to carve out a V-shaped valley as opposed to glaciers which carve out a U-shaped fjord. So when the glacier melts and the ocean inundates it, we would call it a fjord. So these are drowned river valleys, and there is also the Narragansett Bay up here, which is another drowned uh, uh, plain estuary, and so on and so forth. So they are common along the east coast and the Atlantic coast, and they form large bays. There are many bays down the east coast. Moving down on the other side of Florida into the Gulf Coast. Gulf Coast, as we saw, has a very low tidal range. It's quite protected all around, almost semi-enclosed because of the Caribbean islands at the open mouth, and then you have continent around it, Mexico all the way down. And the wave energy is obviously generally low. It's tectonically subsiding because it was ahead of the glacier during the last Pleistocene. So it was raised and now it is sinking because the glacier has melted. Mississippi Delta dominates the Gulf of Mexico. So the sea level is rising locally due to compaction. So a lot of sediment comes in from the Mississippi River and it doesn't get transported out as easily. So the sediment keeps getting compacted. This is also happening in the Bay of Bengal. As I mentioned, Himalayan rivers, the rivers that originate in the Himalayas have the largest sediment loads in the world. So that compaction sinks the land and sea level locally rises relative to the land. So average erosion rate is very large, 1.8 meters per year. 2 meters per year is a lot. You're going to lose 20 meters in 10 years. So if you're close to the water, you know that's not a good thing, right? So when we talk about hurricanes, we will talk about some of the problems here. Okay, I mentioned it before when we looked at air-sea interactions and hurricanes, but we'll come back to it in global warming. So Pacific coast, as we said, plates interacting with each other and pushing the US plate up, so it's tectonically rising, experiencing less erosion than the Atlantic and Gulf Coast because it has already lost most of its soft material and turned into headlands, arches, and so on and so forth, sea stacks and so on. It's got open exposure to high energy waves. Now go back to your westerly winds, fetch, duration, and strength, and remember what we said. Because the Pacific is so large, you have a long fetch over which the westerly winds are bringing all that wave energy and depositing at the coast. Good for surfing, but bad for erosion, except the material is hard, so it's not eroding as much as the Atlantic coast, which is a depositional coast. Winds are coming off the land on the Atlantic coast, but it's exposed to storms, hurricanes and nor'easters. So you have to remember all these combinations that determine the net erosion rates at any given place. Okay, so average erosion is just about 0 per year, nothing to worry about, and we will look at some more issues as we go along in the next chapter as well, as we do regional circulation and so on, and we'll come back to many of the related issues in global warming as well. Okay.